All right, hi everyone, and welcome back to the second video going through part 6 of Target 22, the last one in our Unit 7 note packet. And so we introduced um, standard form for the equation of a circle, right? And we recognized how um, the center and the radius are the pieces of information that are contained within that equation. We find the center by looking at the h and k. It's the opposite of what we see as h and k within our parentheses. And then our radius is the square root of the number that we see on the outside, right? And so we can work that forwards and backwards. We identified those things in the first example, and then we use those things to write equations in the second example. And now we're trying to look at the picture of a graph in order to identify center and radius and write equations as well. And so if we need to identify, right, if we need to write the equation, we need center and radius. And so that's where we're going to start in these three examples, A, B, and C. We already did A and B, so let's go to C. So again, we need to find the center here. And so to me, that looks like our center is sitting right about there. And so we need to identify what the point of that is, right? And so it's h comma k, right? X value, y value. And so let's just make sure we see that we're counting by twos again. And so in between each one is a 1, right? And that's -1. -2 is on the line. And so our dot is sitting at -3. Ooh, I'm sorry though. That's a y value, right? -3 because we went down 3. So then as far as the x value goes, how far left and right do we go? Well, it's sitting right on the y-axis. We only went down. We didn't go left or right. And so that means 0. 0, -3. Now, our radius. Remember, our radius is how far away are we from the center to the edge of a circle? So if our center is right here, let's find the edge of the circle. And right, if it's 3 units below 0, and the top of that circle is right at our x-axis, which is 0, then that radius is 3. It takes 3 units to hit the edge of the circle. And so now we can write this equation. Remember, it's an x minus the x value. So x minus 0, parentheses, don't forget the square. And then we'll put a plus, and then it'll be y minus the y value. And this is y minus -3. So that's where we'll see a y plus 3. It's always the opposite. Don't forget the square. And then it equals our radius squared, right? Our radius is 3, so 3 squared. Now we're going to do this in separate steps again because this -0, you'll never see that again because -0 doesn't do anything. So they'll just write this as x squared and drop the -0 part. And then they'll give us plus, and the y plus 3 stays because that's important. And then it'll equal 3 squared, which is 9. So there's your equation. Now, let's work those problems backwards. If they give us the equation, can we graph it? And so in order to graph it, what we need to know, just like always, center and radius. So let's figure those out first. Our center here is, remember the opposite of what we see with the x parentheses and y parentheses. So we see a +2, so x value is -2. See a -6, so +6. And then our radius is the square root of the number on the end, so square root of 16, which is 4. And so here's how we're going to graph our circle. Let's put a dot at our center. So if I find -2, 6, that's right here. I'm going to put a dot there. Now I'm going to draw something, I'm going to erase it. But basically that's the middle of our circle. So our circle is something like that, right? But we need to find out exactly where it goes. And so I'm going to put 4 dots based on my radius. And so I'm going to go from my circle and I'm going to count up 4. Put a small dot. And then I'm going to go back to my center and count right 4. Put a small dot. Back to my center and count down 4. Small dot. And then back to my center and count left 4. Small dot. Now, the reason why I did all of that is because, remember, our radius is 4. And as long as we're going straight left and right, or straight up and down, we can just count those boxes. And so I'm counting 4 in all directions because our radius has to be 4. And remember, its radius is always the same no matter which direction you're going. And so once I put all 4 of those on, I'm just going to do my best to draw a circle through them. And that is our actual circle. And so what we want to do is put a dot at the center and then put 4 dots up, down, left, and right, the radius number away, and then circle through those 4 dots. So let's do that again. The center for this circle is going to be, remember, opposite of what we see in the boxes, +2 minus 7, and so -2, comma, +7. And then our radius is square root of the number on the end, square root of 9, which is 3. And so we are going to put a dot at our center, -2, 7. So left 2, up 7. 1, 2, 3, 4, 5, 6, 7. Dot. That's our center. And then we need to count in all 4 directions 3 boxes. So 3 units above, dot. 3 units to the right, dot. 3 units below, dot. 3 units left, dot. And then we just circle through the outside dots best you can. Obviously, I missed a little bit, but that's pretty good. That's what our goal is right there. And so let's do it one more time. Let's identify our center. This time, right, x comma y, it's the opposite. So we see a +4, so x value is -4. And then y value, nothing there. Why is there nothing there? Well, it's just like what we had in this example, right? We get a y squared when it starts as a y minus 0, and then the -0 can go away. So what that just means in this equation, that our y value of our center is at 0. And that's why we just see y squared. Then our radius, again, square root of the number on the end, so square root of 25, which is 5. So let's put a dot at our center, -4, 0, right here. And then we'll count 5 up, down, right, and left. 1, 2, 3, 4, 5, dot. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we just loop through those outside dots the best we can. And there's our circle. Once again, completely dealing with center and radius. That is basically everything that matters within a circle. All right, a couple more examples here. Now, these ones can be kind of tough, and these bring back some old skills, so follow closely here. We want to write the equation of this circle. They give us the center, and so that's awesome. I might as well just start writing this equation right now, and then you'll see kind of what we have to do once I start it. Remember, my circle is always x minus my x value, which is 5, squared, plus, and then y minus 0 squared, and then that equals r squared, right? But we don't know r up here. We don't know r. It's our question mark right now. We got to find radius. We know some other random point, but we don't know our radius. And so how can we find it? And here's what we do. Let's use our graph and let's put a dot at our center. 5, 0 is just 5 units to the right, no units up or down. So 1, 2, 3, 4, 5. That's our center. Now I'm also going to put a dot at -1, -2. So left 1, down 2. So that point is on the edge of the circle, which means in general, our circle is going to look something like this, right? But we don't know what r is, and so we can't just write the equation yet. But what we do know is if we connect these dots, however far that is, that's going to be what r is. So how can we figure that out? Well, Pythagorean theorem. Drop boxes down and over, and that creates a right triangle, right? And on the right side, that's 2 units. On the bottom side of this, it is 1, 2, 3, 4, 5, 6 units. And remember, our we're going to do Pythagorean theorem here. Remember, that is a squared plus b squared equals c squared. And c is always across from our 90, so that's where our r is. And so if we want to figure out our radius, we will do 6 squared plus 2 squared, and that'll equal r squared. Now, normally we do this, and then we take the square root of the answer we get, but take a look at this. We actually don't need to find our radius, right? Because our circle equation uses r squared in it. And this Pythagorean theorem is set up to just give us what r squared is. So all we really have to do is square 6 and 2 and add them together, and that equals r squared, and we can stop there because we want our equation to actually equal r squared. So 6 squared is 36, 2 squared is 4, that's going to equal r squared. 36 plus 4 is 40, that equals r squared. Now again, if we wanted to know the radius, we could square root 40, no problem. But then, in order to write it back into our equation, we'd have to square it again because our equation needs r squared. So once we get r squared, we can just stop, right? That's what we want to write in the r squared part of this equation. So let's finish this. We knew our center was -5, 0. And so we'll have an x minus 5 squared plus, and now we don't need our -0 part, so we'll just put a y squared, and then that'll equal r squared, and remember we just found r squared to be 40, so it'll equal 40. And that is our answer. And so let's go do that again over here, right? We have a center, we have some random point it goes through, and let's use that information to write our equation. Now, remember, we can start most of this equation because we know our center. And so most of our equation is going to be x, and then minus -3, so x plus 3 squared, and then plus, and then y minus 4 squared, and then that'll equal our r squared. We need to figure out r squared again, right? So let's put a dot at -3, 4. So left 3, up 4. That's our center. And then we'll put a dot also at 2, -2. That's the point this goes through. So our circle is going to look something like that. We don't know exactly, but we need to find this distance here because that equals what our r is, right? Any line from the center to the edge of the circle is always what your radius is. Now to find that, we need to make our right triangle by going down till we get to the level of that dot and then over till we hit the dot. And so let's count these boxes and figure out what the sides of our triangles are. 1, 2, 3, 4, 5, 6 on the left. 1, 2, 3, 4, 5 on the bottom. Remember that creates a right triangle, meaning in a squared plus b squared equals c squared. Our r is our c, and so we need to solve 6 squared plus 5 squared equals r squared. 6 squared is 36, 5 squared is 25, that equals r squared. Add 36 and 25 together, we get 61, and that equals r squared. And remember, normally in the Pythagorean theorem, we square root, but we don't have to here because ultimately what we want is r squared, and so this is the number we can stop at. And so then our final equation is going to be x plus 3 squared plus y minus 4 squared, and it equals r squared, but we found r squared to be 61, so it equals 61. And there is our equation. All right. One last problem. Let's do this one after break, or out on the next video. The only thing I want to talk about real quick is let's add a problem D here, and we're going to talk about the point 8, 5. 8, 5 as well. All right. So I'll see you on the next video to do this last problem. Thank you very much. Keep working hard.